Block 1. The observer effect. Is reality conditional? Hey everyone, and welcome back to the channel. Today, we're not just dipping our toes into a weird idea, we're taking a full-on swan dive into one of the most reality-shattering concepts in all of science and philosophy. Get ready to question everything you see, touch, and believe to be real. The central idea is this: what if our universe, our tangible, solid reality, only fully exists when we're looking at it? Imagine a high-end video game. The stunningly detailed world you see in front of you is rendered in real time. But what about the city over the mountains, the rooms you left behind, the entire continent on the other side of the map? They aren't being rendered. To save immense processing power, the game engine only generates the world that is within your direct field of view. The moment you turn around, the world behind you de-renders into simple code, and the world in front of you springs into existence. Now, what if I told you that this isn't just a clever programming trick for video games, but potentially the fundamental operating principle of our own universe? This mind-bending concept is rooted in the bizarre and counterintuitive world of quantum mechanics, and it's known as the observer effect. At its core, the observer effect describes a phenomenon where the very act of measuring or observing a particle fundamentally changes its state. Before you look, a particle like an electron doesn't have a definite position or a definite speed. Instead, it exists in a ghostly state of all possibilities at once, a mathematical concept called a superposition. It's everywhere and nowhere simultaneously. It's a wave of pure potential. But the moment you try to measure it, the moment you look, that cloud of possibilities collapses and the electron is forced to choose a single definite state. It snaps into a specific location, as if it was there all along. The act of observation doesn't just reveal reality, it seems to choose reality from a menu of probabilities. A simple analogy to grasp this is to think of a spinning coin. While it's spinning in the air, you could say it's in a superposition of both heads and tails. It's neither, and it's both. The moment you slap it down on the table, the moment you observe its final state, the superposition collapses and it is definitively either heads or tails. In the quantum world, it's as if the universe is full of these spinning coins, and our consciousness, our measurement, is the hand that slaps them down, forcing them to pick a side. This is the essence of wave-particle duality, one of the cornerstones of quantum physics. An unobserved particle behaves like a spread-out wave of probability. An observed particle behaves like a solid, predictable billiard ball. So, why would the universe be built this way? It seems inefficient and needlessly strange. This is where the simulation hypothesis comes roaring in. Proponents of this idea suggest that what we perceive as a physical law, the observer effect, might actually be a technical feature of a simulated reality. If you were to program a universe of this scale, with trillions of galaxies containing septillions of particles, the computational load would be literally astronomical. Rendering every single particle in a fixed, definite state at all times would be an impossible demand on any computer, no matter how advanced. What's the solution? You program the system to conserve processing power by only rendering details when a conscious observer queries the system. Our act of looking, of measuring, is that query. It's a ping to the cosmic server that says, hey, I need the data for this electron right here. And the system obliges by collapsing the probability wave and serving you a definite result. This is reality on demand. It's a universe that loads just in time. The famous physicist John Wheeler once put it this way: no phenomenon is a real phenomenon until it is an observed phenomenon. This challenges the very bedrock of our understanding, suggesting that reality isn't a static, objective stage we walk upon, but a participatory event that we help conjure into being with every glance. This is Block 2, the simulation hypothesis and quantum weirdness. So we've established this bizarre principle where reality seems to wait for a cue from an observer before it solidifies. This isn't just philosophical musing, it's demonstrated in what is arguably the most famous and baffling experiment in the history of science, the double-slit experiment. If the observer effect is the strange symptom, this experiment is the definitive diagnosis of reality's weirdness. And for simulation theorists, it's the smoking gun, the glitch in the matrix that reveals the code underneath. Let's break it down, because understanding this is key to understanding everything. Imagine you have a screen, and in front of it a barrier with two thin parallel slits. You then shoot tiny particles, like electrons, at the barrier one at a time. If electrons were just tiny baseballs, you'd expect to see two simple bands on the back screen, corresponding to the particles that went through either the left slit or the right slit. Simple, right? But that's not what happens when no one is watching. When the electrons are fired one by one without any detector to see which slit they go through, they create a pattern of multiple bands on the screen. This is an interference pattern, the kind you see when waves in water overlap. This pattern proves that each individual electron traveling alone somehow went through two slits, behaving like a wave and interfering with itself. Think about that. A single particle is in two places at once. This is quantum superposition in action. But here is where it gets absolutely insane. The moment scientists place a detector at the slits to observe which path each electron takes, the weirdness vanishes. The very act of measuring, of looking, forces the electron to behave like a particle again. The interference pattern disappears completely, and you're left with the two simple bands you'd expect from tiny baseballs. It's as if the electrons are aware they're being watched and decide to act normal. This result is so consistently mind-boggling that it has stumped physicists for a century. From a simulation hypothesis perspective, however, it makes a strange kind of sense. It's a perfect example of resource management. The code of the universe could be written like this. If no observer is present, calculate the particle's path using the computationally cheap wave probability function. If an observer requests data on the particle's path, collapse the wave function and render a single definite particle at a specific slit. Do not waste resources rendering a definite path unless absolutely necessary. The experiment is like peeling back the curtain and seeing the game engine's optimization tricks at work. The universe isn't hiding its secrets, it's just efficiently managing its rendering budget. This, of course, throws us into a philosophical abyss. What exactly constitutes an observer? Is it a conscious human being? A camera? A cat? This is known as the measurement problem, and there's no consensus. Some physicists, like Eugene Wigner, went as far as to propose that consciousness creates reality, that the universe requires a conscious mind to collapse the quantum possibilities into a single concrete existence. This elevates consciousness from a mere passenger in the cosmos to a fundamental co-creator of it. It's a staggering thought. This also completely reframes the debate on free will. If reality is a branching tree of probabilities, does our choice to observe one thing over another prune the branches and solidify one timeline? Are we navigating the simulation, or is our sense of choice merely an illusion, an emergent property of the simulation rendering its next frame around our focus point? The line between player and program blurs completely. Perhaps reality isn't a static, pre-written book we're reading, but a dynamic, interactive story we are writing with every observation we make. What do you believe? Is our universe a base reality, or an incredibly sophisticated simulation rendering on demand? Let us know in the comments. Subscribe for more mind-bending ideas, and we'll see you in the next one.